this session this morning I'm going to let you know first before we start, right? So this is week 6. Next week is week 7, right? So if you notice, we have a midterm test, so it's conducted in week 7, right? So bear with me. Let me share my screen. Okay. Right. So I've made an announcement in your stream in our Google Classroom. Okay. Right. So I'm just gonna talk a little bit about this very short to just indicate. Right. So our midterm test is conducted throughout the whole of our branches and main campus as well. So it's a concurrent midterm test. Yeah. So that means when this midterm test is held next week, okay, at the same time, other branches and also main campus will have the same, okay, the same test as well. So you have to prepare yourself early, yeah. Just make sure you set your alarm, right? As you can see the timeline here, please take note of the timeline, right? So our test next week is called the FCN midterm test. Actually, it's midterm test conducted online, yeah. Right. So that's the date next week, yeah. 7 Wednesday. Okay, the test will start from 8 to 9:15. Okay, so 15 minutes you are given as the time for your submission, right? Please submit on time. Okay, remember to submit on time, and usually I advise my students don't rely on your too much on your internet connectivity. Sometimes things happen last minute, yeah. So we don't want to have late submission because there will be a deduction of marks, right? So these are the format, right? There are 2 questions. Each question is 25 marks, right? Then these are the scaling of the marks, yeah. Okay, so basically your 50% marks for the test is converted to 100% for that particular midterm test marks, and then converted back to scale back to 30% as part of your coursework mark. So this midterm test is 30% of your coursework mark. The other coursework marks comes from the skill-based assessment. Skill-based assessment means the practical side you'll be using packet tracer in that test, okay, conducted later, okay, towards the end, before the end of the semester, right? You'll be informed. The other percentage coming from your assignment that's already given to you, right? So take note of that. The coverage is between chapter 1 to 5. Okay, so let's have a look at what is chapter 1 to 5. So chapter 1 basically intro to networks. Chapter 2 network protocols communication. Chapter 3 physical layer. Chapter 4 data link layer. Chapter 5 Ethernet. Okay, so that means it covers all the way to last week's chapter, right? Okay, so the timeline, that means you have to wake up early, get ready. Better not to rush. You wake up early, have some coffee or breakfast, whatever, because I know we have a session immediately after that 9:30, right? Like today. So 7:45 you can log into your meet that will be given to you. Okay, during the test itself, you will be all of you will be in the Google Meet that will be provided. All right, so between 7:55 and 8 a.m. you will get your question paper, right? And then you'll start answering the questions, and the last 15 minutes, okay, will be given to you for submission time. So you only have 1 hour to complete to answer the 2 questions. So the 2 questions, each question basically 25 marks, and of course each question will have sub questions for you to answer. Right, so half an hour per question if you want to manage your time, yeah. Right, so here is the penalty for late deduction. Right, okay, late submission, 5 marks will be deducted from your total mark. Okay, right, so if you're very late, 9:46 onward, then you don't get any marks from your e-test. Right, that will severely compromise your coursework marks, so please take note of this. Right, I have to announce this, cannot do any cheating or plagiarism. And plagiarism here means you just basically answer questions based on the notes and copy paste the notes, or copy paste from from Google or something like that, right? Those are considered plagiarism. Cheating basically to collaborate each other or other students, other branches or main campus. Okay, all right. So no collaboration. This is your own work, huh? All right. So if you are going to be absent, please provide solid evidence. Here is based on it will be based on case-to-case basis lah. Of course, for example, if you fall sick, right? Fall sick, then of course cannot force when you're sick, right? So you have to provide like some kind of medical documents or whatever. All right. All right. So that is, and I want just to announce to you that also I have already, if you've been using the NetAcad, you will notice that you're able to access the chapter exams for the chapters that we already covered. Okay, those are MCQ question online on the NetAcad, and I suggest you go through it lah. That means as a revision, right? As a revision is MCQ. Of course, our own midterm test will not be MCQ. It will be written test, but you can use the NetAcad questions for your own revision, because the coverage is quite good. Coverage is quite good, and the questions, even though MCQ, you actually you have to think a bit further to answer the question online. Okay, so the NetAcad questions are really open up for you guys for you to do your revision. So please make use of the NetAcad in addition to our slides for your own revision. All right. Okay, so any question on that? If you have any question, of course, please ask me. Now, if you look at our course plan, now it's week 6, right? So we've finished Ethernet. We're going into chapter 7. Chapter 6 will be covered later on in week 12. Okay, and you can see network layer routing and routers. Okay, we're going to cover that later on. But we're going to put more emphasis on chapter 7, 8, and so on, because we want to introduce to you the IP addressing. IP addressing also basically resides in network layer. Okay, but we want to focus on the IP addressing instead of the routing part of the network layer first, right? So chapter 7, if you notice, is there's quite a lot of grounds to cover. Let me just show you. About 93 slides. 93 slides. Some of them maybe we go very quickly, but if I'm going too fast, please let me know. Okay, but we do need to cover them because chapter 7, week 7, we will cover chapter 8 already, and we'll start to look at subnetting. All right, so we might encroach into parts of our tutorial this week, unfortunately, but don't worry, I will cover I'll make sure we cover the Ethernet questions. All right. Without further ado, let's get straight to it. Okay, so we leave behind the Ethernet chapter and we go into network layer. As I said before, network layer is where we do our routing, but we're going to uh, leave it for later, the routing part. As you know, routing means the forwarding of packets between networks, right? And we want to start off with IP addressing. IP addressing, as you know, is logical addresses that is part of the network layer. So let me start recording. And we can start, yeah, our lecture to this morning. Right. So this is a coverage that we're going to look at. Okay, we basically divide into two major sections because IP address right now we are looking at two versions. The IP version 4, which is what we've been using and also still currently use, IP version 4 network addresses, right? And then the second part, we're going to look at the IP version 6. This is the future that we hope to get into, right? But we are already some ISPs, a majority of ISPs, and also people and organization are in the midst of transitioning, okay, from IP version 4 to IP version 6. This transition period will take some time, right? Uh, uh, we can never do a direct crossover from IP version 4 to IP version 6 due to the many uh, devices, okay, the hardware and software that needs to be upgraded to support IP version 6, right? So we'll be moving there, and we're in the midst of doing that, but needs some time. But because it's a very important protocol, this is the future protocol, so we're going to cover IP version 6 as well, right? Right. And connectivity verification, as we know, is using ping. Okay, there are ping for IP version 4 and also similar protocol for IP version 6. All right, and both IP version 4 and IP version 6 relies on this ICMP. Okay, ICMP to actually perform the ping, which is it's basically use ping to verify connectivity, right? And the other type of connectivity that I want to talk about is the forwarding of packets between networks, meaning via routers. And the second tool that we're going to look at for connectivity verification is the traceroute utility. Okay, traceroute utility works a little bit differently from ping, but it's also used to see whether there's any problem with network connectivity. Right, let's start with IP version 4 address structure. Right, as usual, you can find detailed notes online in your NetAcad account. Yeah? Right, so we start with binary numbering. I think we start to realize, but you guys know already, taking IT courses and also the computer architecture organization course. You know, our computers are digital systems, and our data and our instructions are all encoded to work on our computer system, encoded into binary digits we call bits. Yeah, and binary digits basically depending on base 2 numbering system. Okay, so just for contrast, in our daily usage of numbers, we use base 10, or we call decimal system. For the computer, it's using binary system, and binary digits or bits consist of only 2 bits, which is 0 and 1. Okay, right? So IP version 4 addresses are also encoded in binary digits as well, and it's expressed with 32 binary bits. So we have 32 bits used for IP version 4 address, right? And these 32 bits are divided into 4 8-bit octets. Okay, so usually we call 8-bit as byte, right? Byte. But in the terms of IP version 4 addresses, we have a special term for those bytes, 4 bytes. We call a byte section in IP version 4 address as octets. So we have 4 octets. As you can see, 32-bit divided by 8, we get 4. So we get 4 octets, right? And usually we separate these octets by using a period, okay, or a dot, right? As you can see here, okay, 8 bits dot, 8 bits dot, 8 bits dot, 8 bits dot. We are more familiar with decimal numbering. So usually you've seen already, it's a number representing the octet in decimal, then dot, decimal, dot, decimal, dot, decimal. Human readable, we use decimal dot format. For computers, we know computers will use bits, right? So you can see there, right? So it's very important because for some operations later on, when we're doing subnetting, for example, in VLSM, we're going to have to be able to convert between decimal to binary and from binary back to decimal. So for your own understanding and work. All right. So the conversion slides later, I will just skim through because I know you guys are taking the computer organization with Ms. Surani, yeah? So you know about the conversion technique already. All right. So maybe we'll, if you have any question, you can ask me, but maybe we'll skim the part where conversion happens. Now, in our course, we don't really put so much emphasis on the conversion working. Okay, different from computer organization. Computer organization questions, you have to show your working when you do the conversion. Here, as long as you know how to convert, that's fine already. Okay, because we focus on the different things. Right. So for human readable, because when you look at this, it's very hard for us to see. We can see the pattern, but we can't remember the pattern, and we can't make sense of the pattern unless we convert the patterns of bits, 1 and zeros, into decimal notation. So we call the IP address that we normally operate with in terms of decimal base number as dotted decimal notation. Okay, so in questions, when you see dotted decimal notation, we mean this. Okay, the decimal numbers separated by dot. Okay, the dots to create 4 octets. Yeah, right. So if we say it's binary notation, then it's this one. Very clear, huh? Okay. So before we move forward, just watch a short video.
In this video, I'm going to discuss binary to decimal conversion. But before I do this, I want to take a look at positional notation or place values. I have the number 2,168 here. If we look at the place values of the number 2,168, we can see that the place values have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system. You can see that we have the number 2 in the 1,000s place, so we have 2 1,000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60, and we have 8 in the ones place for 8. So effectively, we have 2 1,000s, 1 100, 6 tens for 60, and 8 ones for 8. Now, when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0, the tens place 10 to the 1, the hundreds place 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2,168 then, in long form, we can see that effectively we have 2 1,000s, 1 100, 6 10s, and 8 1s. And 2,000 plus 100 plus 60 plus 8 totals 2,168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system, from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9,168, I'd simply replace the 2 here with a 9, and now I have 9 1,000s totaling 9,000 in the 1,000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, binary is a base 2 number system. There's only 2 characters or 2 numbers, 0 and 1. So under the place values, we can only have 0s or 1s. The place values go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. That's 2 to the 4th power, place value of 16. The 32's place, the 64's place, and the 128's place. Notice that I extended the table to 8 place values. That's because 8 bits is an important grouping of numbers. 8 bits makes a byte in computer processing. So now I have the place values for essentially 8 bits. If I want to write the number 168 in binary, I just have to find the corresponding place values and plug in either a 1 or a 0. So I'll go to the 128's place and ask myself, do I need 128 to reach 168? Yes, I do. So I'll put a 1 there. Now, do I need a 64? I already have a 128. If I add 64, I would get 192 because 128 plus 64 is 192. So the answer is no, so I put a 0. I still have 128 now. Now, do I need a 32? 128 plus 32 is 160. So yes, I could use a 1 here. Now I have 160. Do I need a 16? No, that would make 176, which would go over my target number of 168. I'll put a 0 here. What about an 8? If I add an 8, I'll hit the number perfectly. 128 plus 32 plus 8 is 168. I'll follow this up with 0s in the 4's place, the 2's place, and the 1's place. And 168 in binary equals 101010000. I now have 128, I have 132, and I have 8. And 128 plus 32 plus 8 equals 168. If we go to the next slide, you can see now that I'm now charged with converting the number 01101101 to decimal. If I want to go the opposite way and convert this binary number to decimal, all I need to do is plug it into the place values. I'll put it in here, 0, 1, 1, 0, 1, 1, 0, 1, and then add it up. I have a 64 and I have a 32. 64 plus 32 is 96. Plus I have an 8, that makes 104. Plus 4 makes 108. Plus 1 makes 109. This number converted to decimal is the number 109. Now let's look at a full IP address in binary. I'll go to my next slide. And you can see in this next slide, I now have a 32-bit IP address, 4 octets, or 32 bits total. If I want to convert this binary IP address to decimal, all I need to do is count up each individual octet. Let's start with the first one right here. We can see that 1, 1, 0, 0, 0, 0, 0, 0. 128 plus 64 is 192. Now, the next octet has 10101. Let's do that one. 0, 1, 0, 1, and then all zeros. If we count up the numbers, 128 plus 32 is 160, plus 8 is 168. The next octet is all zeros with a 1 in the last place in the ones place. This is easy. This is the number 1. All zeros and a 1 in the ones place makes the number 1. And then finally, we have a number here. I'll plug it in here into my table. And I have the number 011000101. We can see that 64 plus 32, we've already said, is 96. Plus 4 is 100. Plus 1 is 101. So the conversion of this binary IP address to decimal is 192.168.1.101.
All right, so any questions on that? I believe you guys have already learned how to do this, yeah?
Yeah.
Yeah? All right. Okay, so I'm just gonna forward now. All right, so these are the basically very similar to what has been explained in the video. Okay, please let me know if you need further clarification because I'm gonna skim through this because I know you guys already learned about this in the other course. Okay, so I'm just gonna go. It's all talking about the conversion. Now I do want to talk about that. Since you do not need to work on it manually, right? I mean, no need to show the manual work of converting between binary to decimal, decimal to binary. What we are interested in is that you made the conversion correctly, right? Because we focus on the network process instead of the conversion, okay? Again, I want to repeat that in other courses, for example, computer organization, architecture, you do have to show that because they want to focus on that, right? For us, so I just want to say that it's perfectly okay. Make sure you know how to convert, right? But it's perfectly okay for us if you use the calculator to do the conversion, right? Because what I do not want is you know how to work out the network process, but you get it wrong because of your conversion is wrong. So if you prefer to do manual conversion, fine, but always double check your answer using the calculator, right? But as revision for your other courses, of course, if you do manually, it will be better. Okay. As you get used to the conversion process, I believe that you can do it even faster than the calculator, right? Right? Okay. So these are all conversion until here are conversion examples. So I'll skip that because please work on it yourself. Right, so here I want to introduce to you the format of the IP version 4 address. Okay, so there are two types of information that we need actually, when we talk about addressing at the network layer. Okay, one is to provide a unique address to the host or interface. Okay, right, host for end devices is a host, but interfaces we want to refer to interfaces of a router, okay, the network layer device, right? But at the same time, we also need the second information, which is the network address. The network address is used by the router, okay, to identify the network that is attached to its interface so that it can make the routing decision. Okay, imagine a router, okay, receive a packet. From the packet, the router will de-encapsulate up until the network layer and look at the network layer header. Within the network layer header, there's a destination IP address. The router is interested in that. Okay, from the destination IP address, the router needs to extract the network address, and then the router will need to look at the network address in order to compare against the network addresses it has in its routing table. Okay, if there's an entry, okay, matching entry, then it can then look at the map interface, right? Which interface that network address, okay, can be forwarded. The packet can be forwarded to. So from there, the router can then make a decision. Okay, this packet needs to be routed via this interface. Then it will forward it along. All right. So that's why when we look at the IP version 4 address, it has both network and host portion. Okay. AKA an IP version 4 address is hierarchical. It's composed of network portion and host portion. Network portion to identify the network, host portion to identify the host itself. Okay. So all the devices, okay, that belongs in the same network must have identical network portion. Okay, right? Huh? So if they are in the same LAN, all of them will have the same network address. Okay, so how do we identify the network part of the IP address? Okay, how does the router extract it? It needs something called the subnet mask. Okay, if you want to know what is a mask is if you're familiar with any graphical editing, right? You probably encountered mask before. A mask is used to hide certain parts, okay, certain parts of an object. Okay, so subnet mask, okay, is used to hide the host part so that we can look at the network portion. Okay, subnet means is another word for LAN or network. If you expand subnet means subnetwork. Okay, so you combine those together. The subnetwork mask, and the mask is used to mask the host part so we can get the network portion. That's why subnet mask can help devices to identify the network portion, right? Okay, so because it can mask, the mask can help mask the host portion, so we can retrieve network portion. That means using the subnet mask, we can also know what is the host portion. So its use is to basically separate, okay, from one IP address, it can actually extract for you what is the network portion, what is the host portion. All right. So that's why when we go into the configuration part, okay, configuration part of the network layer inside your operating system, okay, what we call as providing the interface IP address. Okay, not only we need to provide the IP address, as you can see here, right? Not only can we manually enter the IP address, but we can also we also must provide the subnet mask. Okay, right? So the third field here is called the default gateway. The default gateway allows devices or end devices within a LAN to be able to know where to send packets that don't belong in the same network. So if we know that this is the network part, okay. So any packet destination address which do not have this network part means it has a different network part, right? So for example, if you want to say you want to you open up your browser and then you want to access Google IP address will have different network part. Okay, so obviously when it's not the same, our devices know, oh, okay, this packet cannot be inside this network. It has to go outside of this network, right? So the default gateway is basically the router whereby our packets can travel outside of LAN. So the router can forward our packets outside. So to identify that router's interface that allows our packet to go outside our LAN, we need to provide an address. Okay, so every end devices, when before they will send the packet to the switch, okay, to be forwarded. Of course, the switch don't look at IP address, as we said before. The switch will look at the MAC address, but from the network layer point of view, we want to send a packet to an end device. Okay, when the end device look at the before sending it out, look at the packet, the header. It looks at the destination network address, and it's not matched with any of the end devices routing table. Then it knows it can only send it to default gateway, right? Default gateway. That's why it's important if you don't fill in the default gateway, your packet cannot be routed outside of your own network. Okay? Right? Just now, any question?
Is it possible for there to be two of the same IP address?
No, it's not possible because there will be confusion. IP address work on the idea that all IP address, okay, has to be unique. Now, but I will have to qualify that. Later on, we'll see that there are different ranges of IP addresses. Okay,
Yeah,
yeah,
ranges, like
ranges.
the numbers have meaning.
Yes.
Oh.
Because initially, when the internet was not the internet, it was quite small. 32-bit seems to be a lot, right? Seems to be oh, this so much addresses. So many addresses. Okay, at that time now, at the beginning, right? So yeah.
So in the past, when there's no IP address, it's very messy.
No, in the past, there were so many possibility. There are so many IP address. There are very few computers. Okay, the internet was not even, it's not like what we have now, right? So it seems to be the IP address range, 32-bit range is more than enough. Okay, let me just very quickly, highlight to you the size of range of 32-bit. So 2 to the power 32 lah, right? That means it should be if every end devices has this an IP address, we have 4 billion, roughly 4 billion IP address to go around. But think about now. Last time 4 billion seems wow. When a personal computer just came out, very few people has it. Typically network dominated by mainframes. Okay, so 4 billion seems a lot, but now 4 billion is nothing. right? So that's why then they have to adjust. They have to adjust the IPv4 protocol a little bit, how they use it. All right. So that's why if you say, can there be a duplicate? Definitely. If you want to be on the internet, from the internet point of view, you must have a unique IP address globally. But from the point of view, now we have to make do with only this is similar 4 billion, but now it's not, it's actually inadequate already. So we have to use kind of a trick lah, right? So we're going to cover that. Don't worry, we're going to cover that later on in this chapter. So I don't want to delay. So I'll let you know when we reach that stage. We'll cover this back again. Okay. So the answer for now is yes and no. Yes, because that was the intended use of IPv4. Every end devices must have a unique IP address globally. But no, in the sense that due to the 4 billion, even with 4 billion, not all can be used, and also it's already run out. So they have to do some trick whereby they will have the duplicate, but the duplication doesn't really affect the global network. All right. So okay, so keep that in mind. Put a pin on it. Later we'll cover that back again. Okay, we're gonna go through those slides later. All right. So right now, just look back onto Subnet Mask. Right. So this is what you're looking at here, right, is how the Subnet Mask works, right? So usually this is an example of an IPv4 address 192.168.10.10. So before we go further, what is the maximum number you can have here? So again, I want to use the calculator to help us go a bit quicker. Right. So if we go to programmer, we go to binary. Remember, each octet is actually 8 bit. So if we want to know what's the maximum 8 bit number is, we just type 1, fill up all ones for the 8 bit, and you can see there 255. That's the largest number. Okay, that's the largest number you can have in each octet. If you have larger than 255, something is wrong already, your calculation. So the range is between 0 to 255 for each octet, because the maximum is 11111. So subnet mask, okay, for subnet mask, the rule is this: the network part or the network portion of the IP address, okay, is indicated by the subnet mask by being all ones. So let's say we divide the IP address into network and host, and we use the third dot. So that means the network portion has 3 octets, host portion have 1 octet. When we do the division like this, how we know what is the subnet mask is, or how the subnet mask format is done is, for the network portion, replace all the bits with 1. Of course, all ones means 255. So in decimal, we'll see 255, 255, 255. And then for the host part, for the subnet mask, all bits convert to 0. So all 0 means 0. Okay? So for this IPv4 address, its subnet mask is 255, 255, 255, 0 because of this pattern. Okay? It's always, this pattern is a format already. How to write the subnet mask. Okay. Network part all ones, host part all 0. Alright. Okay. So how does the router extract network address from an IP address? By using the network, by using the subnet mask. Given an IP address, in order to work with this, you need to do a logical AND. Okay, from the truth table, N truth table. Okay, this is N truth table. Okay, logical AND one. You only get one if 1 and 1. Both operands are 1, then you get 1. As long as you get 0, the result is 0. Okay, keep that in mind. This is the truth table for AND. And we're going to use this logical AND and apply to the IP address and subnet mask. But of course, you need to convert decimal to binary and then perform the logical AND. Okay, so let's do that. Right? So we have the IP address, we have the subnet mask. We perform logical AND for each bit. Okay, but because of the truth table, we know already lah. For us, we know already. Okay. Because this the mask is a 1 here, so any ones here will be ones here as well. Can you see the pattern? So when we convert, of course, we get 192.168.10. But no matter what number here, because our mask here is 0, it will always be 0. So the resultant, okay, answer, when we do the logical AND between the IP address and subnet mask, we get the network address. So this is the extracted network address. Okay, now why is this important, this process? Because this is exactly what the router do. Okay, the router, when you receive a packet, it de-encapsulates the network layer, it gets the destination IP address. Okay, it gets the network, the subnet mask, it performs logical AND, and it can then get this network address. Okay, very important part of the router. Okay, to extract this network address from the IP address using the subnet mask to perform logical AND to get it, this one. Then the router, as I mentioned before, will then use this network address to compare against entries inside its routing table. The routing table simply just have this network address mapped to interface. Okay, network address interface. Okay, so if this network address match with any entry, then you just have to look at the interface. Then you know, okay, for this packet, I forward through this interface. If no matches, what happened? There's a default route. Default route is set by the network admin. If nothing match, forward through this interface. That's the default route. What happens if there's no default route? The packet is dropped. Okay. Okay, but important thing on this slide is you know how to do this logical AND. Convert your decimal IP address into binary. Convert your subnet mask into binary. Perform logical AND and get the result. Convert back to decimal, and you'll get network address. Any question here?
No.
Should be okay, Please let me know if you're not sure. Okay, we'll move forward. Right. So sometimes it's very hard to just, to know the pattern. Okay, to write out the entire pattern, to write out the decimal is too long. Okay, so there's a way to indicate subnet mask. We call the prefix length. Prefix length is simply a slash followed by the number of bits belonging to the network part. Okay, so if you look at it, let's say you have an address and it's, there's a prefix, okay, /8. So what can you tell about this /8? That 8 indicates how many bits belong to network part. So 8 bits means 1 octet belongs to network part. The 3 other octets belong to host part. If we follow the rule of subnet mask, network part all ones, host part all zeros, then from the prefix we can build our subnet mask. As you can see, only 1 octet belongs host, so 255, the rest all 0. /16 means 2 octets. /24 means 3 octets. /25 means, okay, so now we are going beyond, not based on each octet anymore. Okay, we can actually go bit by bit. /25 means here is 8, 8, 8, and a 1. 8, 16, 24 plus 1 bit is 25 bits. So how do you convert this? Well, we know all ones at bit is 255. So this 255, 255, 255. But this one, 100000, right? So if you convert this 10000000 is actually is 128 decimal. So take note on this. It's not necessary that the host part, okay, will always be 0. It depends on the prefix length. How many bits belong to the network part, right? So for example, let's say /30. So 8, 16, 24, then we count bits, 24, 25, 26, 27, 28, 29, 30, all ones. So here 25, 255, 255, 255. But this one is 1111100. So when you convert to decimal, that's 252. Okay? But the rule is still the same. The network part is all ones. The host part is all 0. So if only two bits belong to the host part, how many host address is available? Well, it's only 2 bits, right? 0, 0. So the formula is 2 power n. N being the bit. So 2 power 2, 4. So for /30 prefix, you only have 4 host address. Do you see that? Well, they are, because 2 bits only, right? 0, 0, 0, 1, 1, 0, 1, 1. Only 4 patterns. So only 4 host address. Remember why we say that? Because these 4 must have the same network address. So the network address you give must be the same. The only way to differentiate them is using these 2 bits, the host part. And 2 bits give us only 4 patterns, 0, 0, 0, 1, 1, 0, 1, 1. So that means only 4 host addresses. Okay, so when you look at the address and you're given prefix length, even if you're not given the subnet mask, you can actually recreate the network mask. /24 means 24 bits belong to network part. Okay, so 8, 16, 24. This one ngam fit. So 255, 255, 255, and the rest host part are 0. So that's your subnet mask. Any question on this?
Is it possible to have 32 bit?
Yes, it's possible, but then your addressing, there's no point lah. If you have 32, mean all will be a network address. That means there's no host address, which means your network do not have any host, and it's non-functioning lah.
Oh,
Yeah. So it's possible, but it's not realistic. So the most you can have is actually /30. More than that, then it's non-functioning. Your network is non-functioning. Okay. Of course, possible. Yeah. Good question, actually. /31, /32. Yes, you can, but cannot be realistically applied in the real world, because then that network serves no purpose, because it's non-functioning. There's no host address. Even with 31, you leave you with 2 host address. So 2 host address, one used for network, one for broadcast. No leftover for host. Every network range must have a network address and broadcast address. So if you /31, you get only 2. Okay, 0 and 1. So one belongs to network, one's to broadcast. There's no host address. /30 is the maximum prefix length you can have, because it gives us 4, 1 network, 1 broadcast, and 2 hosts. And typically, you can see /30 in this configuration: router, the 2 host address is this and this. Okay, so whenever you see /30, you know the configuration in the network will be a network that links 2 routers together. You get 4 host address. The first address is meant for network address. The last address meant for broadcast address. That leaves you with 2 unique host address, which is used for this interface and this interface. Okay, and you go beyond /31, then you don't even have the host address. So yes, you can create it, but can't be used. Okay, huh? So move forward. This is what I meant. For every network, it will have network address, a range of host address, unique host address within that network, and broadcast address. Broadcast address is used to perform one-to-all. Okay, one-to-all communication. Network address is used to identify that network. Host address is used to provide the end devices within that network with a unique IP address. So the pattern is always like this, as you can see here, right? The plus is functional online in your NetAcad. Here it's not functional. Here is just it's not interactive. Yeah, if you go online in NetAcad, it's interactive. You can click on the plus to see. Yeah, so right within the range of addresses at the host part, these are all called host address. This is okay. These are host addresses. This is called the usable host addresses. Okay, usable because the host address are the IP address that you can assign to end devices and interfaces. Network address is used to identify that LAN's or network's address. Okay, for the purpose of routing. Broadcast address is used in a one-to-all communication within that network, right? So network address is usually the first address in the range. Okay, the first address in the range. Broadcast address is typically the last address in the range. This is fixed format. Okay, so you'll see the pattern for the host portion. Usually, if it's not subnetted, we're going to talk about subnetting later. In a normal network, which is not divided yet, when you see all zero, this is all zero means for the host part, it's the first address, so that is the network address. Okay, when you see all ones in the host part, because that's typically indicates the last address, you know that that is a broadcast address. And the range in between are the host addresses. Okay. All right. We move forward. If you have any question, just ask directly. Ask me directly. All right. So let's relax a bit and watch this video.
This video will cover the process of ANDing as it relates to discovering the network address, the host addresses, and the broadcast address in an IPv4 network. In this example, we'll assume that our IP address is 192.168.1.100/24. Our goal is to answer these questions. What is the subnet mask? We can see that the subnet mask is /24 in slash notation. But what is it in dotted decimal notation? 2, the network address. The network address is the first address in the network. It's a reserved address that cannot be assigned to any host on the network. What is the broadcast address? The broadcast address is the last address in the network and is also a special reserved address that cannot be assigned to a host on the network. And then, since we can't use the network address and the broadcast address, what is the first usable host address on the network? And what is the last usable host address on the network that we can use to assign to hosts, whether they're PCs or printers or servers or access points, whatever? We'll start with question 1. What is the subnet mask? If our IP address is 192.168.1.100/24, this is our subnet mask in slash notation. The first thing we'll need to do is convert this to binary. So I've converted /24 into binary. Notice that /24 denotes that there are 24 ones in the subnet mask, counting from left to right. If we count them up here, we can see that we have 8 ones here in the first octet. Another 8 here makes 16, and then another 8 makes 24. Now I'll need to convert this to decimal. Converted to decimal, the subnet mask is 255.255.255.0. Now, how did I do that? Recall that we can take an octet of 8 bits and look at it according to the binary place values. The place values start from 2 to the 0 in the ones place, all the way up to 2 to the 7th power, which is the 128th place. If I have all ones in this 8-bit grouping, then to convert it to decimal is simple as adding 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. So each octet with ones in it equals 255. So 255.255.255.0 is our answer. Now let's go to the second question. What is the network address? First off, the network address, to put a simple answer on it, is the first address in the network. So in this case, that would be the address 192.168.1.0. Now you might have assumed correctly that this is the network address. Given a classful Class C IP address like 192.168.1.100 and a classful subnet mask of 255.255.255.0, and you would be correct. The network address is 192.168.1.0. But let's look at it from the perspective of the computer, or for that matter, in the perspective of the router. How does the router know that 192.168.1.100 with this subnet mask has a network address of 1.0? To do this, we take the IP address and the subnet mask and we convert them first to binary. So you can see in this table, I have the IP address 192.168.1.100 here on the upper row, converted to binary. The subnet mask 255.255.255.0 is converted to binary on the lower row. The router and your computer can calculate the network address by combining the IP address and the subnet mask. This process is called ANDing. ANDing, or logical ANDing, is a logical conjunction where we need to figure out whether the statement A and B is true or false, given a value for A and a value for B. So logical ANDing really involves a truth table. If A is true and B is true, then the truth of A and B, with the necessary condition being the conjunction and, is also true. Since A is true and B is true, then A and B, the requirement and, meaning both of them, is also true. But if A is true and B is false, then the conjunction of A and B is false. And if A is false and B is true, then the requirement of and for both of them is false. And if A is false and B is false, then the requirement that they both be true is not met, and A and B is false. We then convert the true and false to the Boolean values for true and false, 1 and 0. And we have a Boolean truth table. The router and the computer use this logical ANDing with 1s standing for true and 0 standing for false to do a logical ANDing operation between the IP address and the subnet mask. So you can see here in the example, the IP address has a 1-bit, the subnet mask has a 1-bit, and the conjunction or the ANDing operation between them results in a 1, or a true and a true makes a true. And so then a 1 and a 1 makes a 1, and a false and a true, or a 0 and a 1 results in a 0. And so now you have all zeros here. And then in the next octet, you have a 1 and a 1 equals a 1. And a 0 and a 1, or false and a true, results in a false. And a true and a true makes a true. And a false and a true makes a false, and so on and so forth. Notice in the final octet, the subnet mask is all zeros, and the result is all zeros. And the resulting network address is 192.168.1.0. This process of ANDing is crucial for how the routers and computers are able to determine the network based upon the IP address and subnet mask. So now we know that the network address is the first address in the network. We also know a little bit more about how the network address is actually determined by the computer or the router. And we can go to question number 3. What is the broadcast address? If the network address is the first address in the network, the broadcast address is the last address in the network. In this case, the broadcast address would be 192.168.1.255. Let's plug the 192.168.1.255 broadcast address into our table and do the ANDing operation just to prove that it's still within the one network. If we go up here to our table, I can replace this 100 right here in this 4th octet with 255. So now you can see that the IP address is 192.168.1.255. If we do an ANDing operation between the broadcast address here and the subnet mask, you'll see that it generates the same result. Notice a true and a true makes a true, true and a true makes a true, false and a true a false, all the way over. And when we get to the last octet, a true and a false is a false, a true and a false is a false. And you can see that the ending result of network address is still 192.168.1.0. Now, if we go to the next higher address and jump up from 1.255 to 2.0, let's say, we'll change it here, put a 1 here and a 0 here. So now that's a 2. And we change this to all zeros. You can see that we're going to get a different result. Notice the ANDing operation. A false and a true is a false, 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 false. But when we get here, a true and a true is a true, and a false and a true is a false. And now the network address is the 2 network, 2.0. So you can see how important ANDing is to defining just where the networks lie. This brings us to the last question. What are the first usable and last usable host addresses in the network? The first usable host address in the network is the first address after the network address. So in this case, the network address is 0, so the first usable host address would be 1. The last usable host address is the address prior to the broadcast address. So in this case, the broadcast address is 255, so the last usable host address would be 254. So now we've answered all 5 questions: the subnet mask, the network address, the broadcast address, and the first and last usable host addresses, given an IP address of 192.168.1.100/24 with a 24-bit subnet mask.
All right.
This video will cover the process.
Right. So I hope that clarifies things. Yeah. Okay. So you can always go back to view our recorded message, also the video just now. All right. So we go to the next section. We identify 3 types of IP version 4 address communication type. So this basically mirrors what we know about the MAC addresses in the data link layer, yeah, because they are actually one-to-one, right? Okay, so let's look at the IP version 4 address assignment to a host. So we know already, the range of usable IP address excludes the network address and the broadcast address. Okay, so let's talk about static IP version 4 address assignment. So static here simply means that it's manually assigned. So if you are the network administrator, okay, so you are tasked with assigning IP address to all the devices within a network. Okay, so usually for wired network, example in our lab, where the computers are the end devices, they are permanent, right? They are permanent, so therefore is permanently attached to within the network. So we don't really need to keep changing the IP address. So usually these are convention. Convention means it's not hard and fast rules, but it is actually the best practice. So if a device is basically permanently attached in the network, it's easier to provide it with the static IP version 4 address. We mean to say we manually assign. Okay, not only is good that because we don't have to worry about keep giving it the IP address, but because it's permanent, right? Then we can assure that if we give it one IP address, then it's fixed until we decide to change our network or upgrade our network or whatsoever. But we fix it. Okay. Another reason is because if those devices are also providing services to other users within the network, for example, here is given printers, servers, right? And also network devices like the interface of our default gateway. because if you keep changing, if you keep changing the IP address, for example, printer, okay, one day your user might connect to the printer using this, because identifying the printer as this IP address. If you change it for the next day, then the configuration for accessing that printer for your users have to change as well. And it's very inconvenient for the user, or if you are the one doing the changing, then you have to reconfigure it. Then keep reconfiguring things like this is very inconvenient and very tedious, and it's not very efficient use of your time. So for devices that is permanently fixed in your network and providing service, with services to your users, it's better for you if you identify, okay, for printer, this is the IP address, or my printers, this is a range of IP address for the printer, and you basically set it permanently, right? So you don't have to reconfigure every time user want to print to the printer, because once you set, let's say, the one user to print to this printer, it means you set the IP address, then it's permanent. Then you don't have to worry about keep changing the IP address. All right? Right? So that's the best practice. When you want to assign IP address to host. Look at the host. Okay, if it's permanently attached, if it's providing services, assign an IP address and stick to it. Of course, as an administrator, you need to document all these things, right? For example, if you assign this address to that printer, because one month from now, maybe you you may not remember, right? So it's good to have documentation, right? Always provide your own for yourself or for other people the documentation ready. Okay, so when you're investigating or you're doing some kind of troubleshooting or whatever, you have this documentation to help you. Or else you don't remember also, even if you assign a static IP address, and you might forget. Okay, what is the IP address, for example, right? So later on, maybe if you need to reformat one of the user machine, okay, so what IP address I have to put for the printer, whatever, you already have that documentation to help you, right? Right. So the second way to assign is by using dynamic IP version 4 address. Okay, dynamic here means it's not manually assigned, it's automatically provided by the DHCP server. DHCP stands for Dynamic Host Configuration Protocol. All right, so this works by request and reply. Okay, computers that is set to obtain. Okay, the DHCP is indicated by you can see there by looking at that. Instead of following IP address, you select obtain an IP address automatically. That basically you're basically asking your OS to request in all this setting. Not only IP address, actually, you ask for IP address, subnet mask, default gateway, etc. And this information is requested from this computer to the DHCP server. Right. So as an administrator, of course, at the beginning you have to set up this DHCP server. You have to configure it to arrange what kind of what range within the usable host IP addresses available to provide to the computer. You can have a mixture in your network. You divide you have one range for DHCP to use to provide to the host that's requesting for this configuration, and you can also statically assign another range of IP address to maybe your permanent devices, right? So the DHCP server at home usually is built into your all-in-one product from your ISP. Okay, but in a enterprise environment, you have to indicate which one of your servers should host this service, this DHCP service. Okay. In our packet tracer, if you use a server, you can see that under the services tab, you can see one of it is DHCP. If you enable that, then you enable the DHCP service to be available inside your network, right? So DHCP server, okay, can provide the IPv4 address, subnet mask, default gateway, and other configuration. Other configuration, for example, DNS services. Okay, provide this the IP address to the preferred and the alternate DNS server. Right? Okay, so what does it mean when it's dynamic? Dynamic means the host that requires this configuration, all this information, will send a request. Okay, send a request, a DHCP request. Okay, and then if the DHCP server exists inside that network, the DHCP server will reply, will offer. And then if the host agrees to acknowledge, and then the DHCP server will then lease. What does it mean by lease? That means we'll give you those configuration for an amount of time. The amount of time is again set by the administrator. Okay. Why this capability of assigning only for a length of time? Because usually this dynamic assignment is used for wireless network, whereby the devices, the hosts are not permanent. The host can come in and out of the network. As the host come in, it requests, because it wants to be part of the network, it requests for the configuration, right? So if you assign permanently, then within your pool of in the DHCP server, within the DHCP server, there's the pool of available addresses. Whenever you assign one, of course your pool decrease, right? If you assign permanently, okay, to a host, okay, sometimes the host leave the network. Actually, the host does not meet the IP address already, but then you have no way of knowing as a DHCP server. All you notice is that your pool of available IP address to lease out to hosts is decreasing over time. By giving a length of time for the lease, the DHCP can recover back some of the IP address from hosts that leave the network. Okay, example. Okay, let's say you go to a Starbucks, you want to drink coffee, and then you want to use the Starbucks wireless network. So you go there, your phone, your laptop, your tablet, whatever, request information. So Starbucks DHCP server give it to you. So for the time that you're using, you are able to access the network, and via the network, you can access the internet, right? But you only drink coffee maybe, or you do your assignment or whatever you're doing at the Starbucks for 1 hour. After 1 hour, you left, right? Now, if the DHCP didn't lease it for just a short amount of time, when you let you're still, even though you're not in Starbucks anymore, because the address was given to you, leased to you already, okay, for a long period of time, then there's no way for the DHCP server to know that you're still there and you're still using, because it doesn't actually detect the connection. Its purpose is only to give to you, right? To you all the address information. That's why if you set up as an admin, you set up the DHCP server, you only provide like short period of time. When the short period of time elapses, if you still need it, the host will request, and then the DHCP server will then decide whether it can give you the same address or give you a different address, but it restart the list again, right? All right. Okay. All right. So there are two ways: static assignment means manually assign this information done by the administrator. Okay. Or dynamically assigned means no intervention by any humans. The host will request the information from a DHCP server within the network, right? Okay, so let's have a look at the three different types of IPv4 communication. Recall the MAC addresses communication. Basically, we have the same similar situation here. So the first one is unicast. Unicast means one-to-one communication, one host to another host. Broadcast means one to all. Okay, and this is the broadcast that we're talking about, the broadcast address. Okay, the IP broadcast address is used for this purpose, this broadcast communication, one to all. Okay, and the third is the multicast communication, which is one to some, or one to many, or one to a select group. Okay, usually the group will decide to join a multicast group in order to be part of the multicast. All right. Okay, unicast one-to-one communication use the range of usable IP address. Okay. Broadcast use the broadcast address, the last address within the network. Right. And for the broadcast, one way to know what is a broadcast is for the host part, you see that there are all ones. Okay, there are all ones in it. So multicast need to use any address within the range shown here. Okay, 224.0.0.0 to 239.255.255.255. Okay, this range of addresses are reserved for multicast. Right? So basically, these are used for the destination address. A multicast address cannot be the source address. Multicast address is always the destination address. Right? So routing protocols use multicast transmission to exchange routing information. Okay, earlier on, I was talking about the EIGRP protocol, routing protocol. They want to exchange routing protocol. Remember, I said about the directly connected and the remote routing information. So in order for them to know where they should forward, okay, then they exchange this routing protocols so that they can update their routing table, right? So as I also mentioned before, not all routers can exchange information between them because there's so many routers. So the routing is done by multicast. So if the router wants to be part of the multicast group, so the router will join the multicast group, so that the routers can exchange between them only, not involve all routers, but only select routers. Okay. Right. So let's have a look at types of IPv4 address. Okay. So this is where I want to highlight just now. There was a question about is all IP address must be unique, and I said yes and no. Okay. At the early stage of the network evolution, there are so few computers, so few networks that 4 billion available addresses, 32-bit, right, for IPv4 seems quite a lot. Okay, but throughout the years, they start to realize, oh, okay, it's not enough. So they start to have two types of addresses. Okay, within the range of the 4 billion, they say, okay, we have public and private IP addresses. The difference is, the public means, when we say public IPv4 address, means these are the addresses that is globally unique, that is used on the internet. Okay. The private IPv4 addresses are the range of address that is available for your own network. Okay, for your own network. Okay, right. So they are for private IP version 4 addresses that you can use in your own network. Whether example would be your own home network, a college-owned private networks, organization-owned private networks. Range there are three ranges. Okay, the first one is the range is 10, 10, 10, 10 up to 10, 25, 25, 25. The network address and prefix is this 10.0.0.0/add. Okay, that means one octet belongs to network address. Then the second range is 12. Okay, 12, not 16. So 8 plus 2 bits. Okay, so that range between 172.16.00 up to 172.31.25, 255.255. Okay, that is the second range of private address range. Okay, typically for us, because our network at home use less, we don't have many hosts. Okay, why we have free range? It depends on how many hosts you have within your network. If you have a larger number of hosts, you will tend to use the first and the second range. If you have less, then you tend to use the third range. Okay, so typically the range we use at home is this one, 192.168.00/16, and the range used within this is this indicated here, right? So those private IP version 4 address are not unique, but it can be used in your own private personal network. Any traffic originating from this network are not routable. Okay, so how then you will ask, how can I access the internet when it's not routable? That's where we use a service called NAT, which we will talk about later. NAT is used to help to route, because we say that traffic from private addresses are not routable. So how do we access the internet? We use this protocol, this service. Okay, we'll talk about that later. So I'm not going to talk here. Right here. Okay, network address translation. Okay, so what happens is your NAT is usually resides within your router. In your home, you're in your all-in-one product. So what it does is basically allowing traffic from your private networks using your private addresses to communicate over the internet. Think about internet only recognize global public IP version 4 address. Okay, so when you subscribe to an ISP like Telecom, right, or TMNet or Unify, okay, you are given one global unique IP address, given the sense that you'll be using the DHCP, not permanently. If you want to have a permanent one, you will have to pay for that static IP address. Okay, and it's only available to you as long as you subscribe to that ISP. Once you don't subscribe anymore, they will take it back. Okay, in order to use it continually, you have to pay for that. At least in Malaysia, if you want a static internet IP address, then you have to pay extra, I think, yeah, extra. Right, so the network address translation service, this NAT, allows your traffic, your host within your network, to able to connect to another host on the internet. Basically, what it does is translate the internal private address to the public global IP address. So imagine if this is your home, probably this one, 192. So the IP address given to you by your ISP will reside here. So this one interface is what the internet public sees. Okay, and sometimes maybe even not. Okay, you are part of another network. Okay, that is used by that is internal to your ISP, and then later on then they will provide a single IP address that is global, depend on the ISP. But make it simple. Let's say this is your home network. Inside you're using 192.168.0.0/24 private network address. Okay, so if the ISP, if you subscribe to them, they allow you to go to internet. They'll normally put this interface on your all-in-one product router facing the internet with the global IP that is seen by the internet. Okay, so the net will translate between your private address and the internet. Okay, the next question you want to ask is, but you know what? I have many addresses in my network at home. They are all non-routable. So how does the router knows? Okay, and this computer communicates with that computer. This computer in my network communicates with that computer. Well, because the net tags each of the packet coming out from the network. It knows this packet is from which computer, this packet comes from which computer, and it tags it. It tags it so that it will change your source address. It maintains a table. It will change your source address from your private to this address. So to the outside internet world, it doesn't see inside your network. Even though you have like 3, 4, 5 devices inside your own private network, what the internet sees is, okay, all those messages coming out from there is one IP. But of course, the net knows. Okay, so when the reply comes back, I know this message is actually coming from that computer in the private network. So I strip it, I change back the address and pass it back to you. Okay, so that's the translation happening by the net. Okay, why we have this complication? Because we are running out of those IP, the global IP range. Yeah, since the internet doesn't see your private address, means any other networks can use the same network address as you. Let's say we don't use that. Let's say I use the same 192.168.0.0 or so /20, exactly the same private address as you, but different network. No problem, because you are separated by the net. What this network see is this, and what you see is this, right? Okay, so one coincidental or maybe planned, not sure, benefit is also, since they cannot see inside your network is secure, right? Your network is secure. It's a good thing also, because we don't want all our devices to be directly connected to the internet. Okay, because the internet is not as nice as it used to be. There's a lot of threat actors on the internet who would love to be able to access our computers. So by using this technique, we are also protected. They cannot simply see, oh, you directly see your computer within your own network, right? So it says edge router. I use this as an edge router, but depending on your ISP, you might be connected to another internal network inside your ISP, and then the IP address, the real IP address will be an edge router inside the ISP's network also. So you may never see what is your it might not be here. I'm just simplifying it. All right. Because it could be the ISP can decide what is the edge router connecting you to the internet. In this way, they can ensure, okay, there's still enough IP address that's global can be used. So we don't really but it's in dire straits right now. That's why we really need to transition to IP version 6. Okay. Any question here?
No.
No.
Oh, okay, good. We move on. All right, so there are other IP version 4 addresses. So far, we've only looked at public and private, right? There is something called a loopback addresses. This is available on every host. Okay, it's called the loopback address. And I think if you are doing any web application or web programming or whatever, you start to notice this. Okay, sometimes we just use the domain name localhost, but the localhost is actually human readable. So in fact, it's actually 127.0.0.1. This is used if your network traffic is not actually leaving your host. Okay, so that means think of this example. You want to write a web app, but you're using your computer as your development computer. So you set up your computer, the web server inside your computer. So you set up your web app inside your computer, and also you're testing it inside your computer, so from your own web browser. So the traffic actually doesn't really go anywhere. But it still need to pretend to go somewhere, right? So the network stack, OSI is inside your computer. So I would say it's only one stack. So it still go down to the physical, but then it goes back up. And how you make it do this is you use this address. This address is basically your own address. Okay, your own address in the sense that it's your own local just looping back again. So this enable you from your own browser to connect back to your own server installed in the same host. Okay, is that okay? So if you want to see whether your network stack is working fine, you run your command prompt and you ping yourself, because 127.0.0.1 is your own self. So you ping yourself. When you get a good reply, means your network stack is functioning fine. Okay, you're pinging yourself. You can ping yourself using your unique IP address, your given for your own private use, but you can also use this. So every host has this loopback address. Okay. Right. The second type of address is the link local address. Now, there will be time when you don't have DHCP server in your network, and you also didn't set any IP address manually. Remember the static and dynamic? Let's say you didn't do both. Okay. So Windows, we use Windows as an example, but other OS also do similar things. Will automatically provide your computer with a linked local address temporarily until you decide to configure the proper address. Okay, it's called the automatic private IP address. Addressing. Okay, you can test this. If you don't have, make sure you don't have a DHCP server. Okay, make sure you don't static your IP address manually. You will see that when you do ipconfig/all in your command prompt, you start to see an address within this range. Okay, so that is configured automatically by your operating system. Okay, and it actually can work, but you have no control over it because it's generated by OS, your OS. Okay, right. The last address I want to talk about here is belong to special user address. It's the testnet address. It's not really being used. This is the range. It was intended to be used for teaching and learning, okay, in terms of networking, right? But we seldom actually use this. Okay. Okay, this range of address is used for if you want to create a network, and that network is supposed to be for teaching and learning, but we're not really using it, to be honest. Okay, we tend to teach you guys with try to use the real network using simulator, and since we have our own private networks, so we use the real private networks to learn. Okay, all right. Moving on to this next slide is telling us about classful addressing. You might have heard the guy in the video earlier on talk about classful. So classful addressing is basically at the beginning of the internet or networking. Yeah, that's why you call legacy. Okay, we don't really use this classful addressing system now. Okay, still IP address, but it's how you make use of the IP address, the kind of ranges. Okay, so it's legacy, but we still need to know because then we know later when we see at the currently used addressing system, we know where it's coming from. Right? So legacy classful addressing, the range of IP address that can be used is put into 5 ranges: A, B, C, D, E. So we call them class A, class B, class C, class D, class E. So to identify if you're given an address and you want to identify which class it belongs to, okay, you can see either you can use the range. You look at the first octet of the address and you see where it falls within the range. For A is 12127, B is 1282191, and so on. Then you will say that, oh, this address belongs to this class A or class B or class C address. Okay, and they are in use. Actually, it's only class A, B, and C. Class D is for multicast. Class E for experimental. Okay, so it's not allowed to use. Okay, now how do we differentiate between A, B, and C in terms of why do they have A, B, and C? Is you can see when we look at the network and host portion of the address. Class A allocates only 1 octet as the network portion, and 3 octets provided for the host portion. Class B assigns 2, half-half 50-50, 2 octets to the network portion, 2 octets to the host portion. And class 3 assign 3 octets to the network portion and 1 octet to the host portion. And when we translate this network host into the subnet mask, you can see it's 2 because network will be all ones, host will be all zeros. So when we translate to the subnet mask, it's 255.0.0.0 for class A, For class B is 255.255.0.0, and then for class C 255.255.255 and 0 for the host part, right? And why is it divided into this way? Is because all networks are not the same. What do we mean by that? For some organization, they want to have fewer networks, but each network they have lots and lots and lots of hosts. Example, data center. Okay. Now, but some organization might want to have they don't want so many networks, but they want just for each they want a lot of networks, but each network have only minimal number of hosts. Okay, so that matches with C. And then some organization are in between, so that falls under class B. Okay, so let's look at what we mean. For class A, you can have 128 different networks. The formula is for number of network is 2 power n. How many bits allocated to the network part? So we say that 7 bits allocated to the network part. Okay, due to the first bit is used for the indication with the class A. So this is 1 to 7. If n is 7. Okay, that leaves us how many usable IP address for host? Well, the formula is same 2 power n, but v minus 2. Why? The 2 are the 2 that we can use for host, which is network and broadcast. So we exclude those 2 because we cannot assign network address and broadcast address to host. So minus 2 lah. Huh? So how many bits for this octet? 24, right? So 2 power 24 minus 2 is 16 million hosts per network. Last time it makes sense because last time the way they do it is we have a mainframe, and each mainframe can basically have thousands of terminals or something like that, right? So we perform the same calculation, host and network, and we notice that class B, because additional octet gives us 16,000 networks, with each network able to provide around 65 or 66,000 hosts per network. Class C provides us with staggering, with the three of course, larger range, 2 million networks. Each network provides us 254 hosts. All right. So what do you notice about these ranges? Can I get feedback? What do you notice about this range? If you're an organization, which one will fit your organization?
B.
B, yeah. But still B. 65,000 hosts within the same network. I think you must be a very big company in order to have that, right? That kind of network. So one thing that you will notice, right, is there's a lot of there will be a lot of wasted address. True or not?
Oh yeah.
Because you only have like these 3 options. Either you are using class A, class B, or class C. Right? Last time 4 billion with 4 billion, the range is 4 billion addresses, and very minimal number of networks and hosts. They think, okay, this is good, all right. They even so maybe they've seen the wastage, yeah, of IP address, but you know, doesn't matter when you have a lot of something. Sometimes you tend not to really care, right? But eventually they start to look at this. Ayo, you know what? We are running out of IP addresses, and this seems very wasteful because not all organizations actually will have let's say class B. Not all organizations will have 65,000 per network. That means 65,000 computers per network. And the worst thing is, hey, what if we have more than 16,000 company if 16,000 companies, not a lot if you think globally, yeah. So how are we going to use this kind of addressing system globally on the internet as the internet connects more and more computers together globally, right? So they start to think about it, right? Okay. So this is their original idea. Class A, we want to design to support extremely large networks with more than 16 million host address per network. 16 million per network. You can think about that. Huh? Class B, support the needs of moderate to large size network, approximately 65,000 host addresses per network. And then this one maybe for smaller businesses, right? So small networks, each network will have a maximum of 254 hosts. Okay, this one sounds more reasonable, right? Okay, so now is 11:30. Okay, I think here is a perfect time for us to go for a break. And let's before we go for break, let's run this and then we'll go for a break. You guys, how long do you guys need for the break?
10.
10? 10 minutes?
Nice.
Okay, 10 minutes. You watch this and then go for 10 minutes break, yeah? Then we come back together.
Okay.
Okay.
First of all, when we're talking about classful IP addressing in networks, we're talking about Class C, Class B, and Class A addresses. Now, what makes a Class C, Class B, and Class A address and network? Two things, the IP address and the subnet mask. In order to have a Class C IP address or Class C network, you need the IP address first octet to be a number between 192 and 223. You also need the subnet mask to be 255.255.255.0. As long as you have these two requirements, you would have a Class C IP address and Class C network. To have a Class B IP address and network, you'd need the IP address, the number in the first octet, to be a number between 128 and 191, and the subnet mask would need to be 255.255.0.0. For a Class A IP address and network, the first octet address number would need to be a number between 0 and 127, and the subnet mask 255.0.0.0. Now you might ask yourself, why these specific numbers, 0 to 127 for Class A, 128 to 191 for Class B, and 192 to 223 for Class C? It all has to do with the fact that the router and the computers see the IP addresses and the subnet masks in binary, not in dotted decimal notation. This is just the decimal representation of what the computer sees in binary. So if we look at it in binary and we take a look and convert the first octet in the IP address to binary, we see that in order to have a number between 192 and 223, the first 3 digits in binary, counting from left to right, need to be 1, 1, and 0. If the first 3 digits are 1, 1, 0, the number has to be between 192 and 223. And for class B, if the number starts with a 1, 0, then the resulting number will be constrained to 128 to 191. And in class A, as long as in binary the number begins with a 0, the number in decimal representation can only be 0 to 127. So the restrictions on the numbers 0 to 127, 128 to 191, and 192 to 223 are due to how the address functions in binary.
Right, guys, we go for a break, yeah?
Okay.
10 minutes, so that means now it's 11:33, so 11:40, 11:34, so 11:45 lah. Huh? Okay.
This video is sponsored by our question. After a long time, the populations will settle to numbers which lie on this line and add to 300, which would be 100 for the humans and 200 for the zombies. Any other
Hello, I am Professor Dork. So we have this triple integral, and so to change the limits of integration, you can draw a picture and then you can change the limits. Let's just go ahead and flip everything around, and that should be okay. I'll leave it to you to verify if this is actually correct. It should be okay, but it is an exercise to the reader, which is you. The top score on the midterm was a 54, so excellent work. There will be a retake exam 2 weeks from now, and it will be curved. So the single integral of a function gives you the area under the curve. So the double integral of a function gives you the volume, and the triple integral of just this also gives you the volume. So if we look at the quadruple integral of this, we end up with the space-time continuum, in other words, the end of the world. Good morning, class. Today we're going to have a quiz at the beginning of class. You have 5 minutes. At the end of class, we're going to have another quiz for another 5 minutes. So the top score was an 85%. Congratulations to Kimberly for continuing her streak of excellence. And the bottom score was a 2%, and we all know who that was. And so we have that the gradient vectors are parallel, and then from this it's easy to see that x is equal to 3, y is equal to -9, and z is equal to -4. So class is over, but if you have any questions, I will be in my office 2 weeks from Monday from 1 to 2:15 p.m. So in this class, the grade breakdown is as follows. So there are some examinations. So the exams, there's 4 of them, and they are worth 70% of the grade. Then there is a final that is worth 30% of the grade. And the homework is just good to do. Okay, so the exam is on Monday. To prepare for the exam, just make sure you read chapters 1 through 12, go over all of your notes, do all of the homework, every single problem, and if you really want to be ready, just do every single problem in the book. So we have to find the partial derivative of z with respect to x. So that's going to be negative, and then we have fx over fy. Oh no, I think first we have to subtract the z. You know what, don't worry about it. This is not going to be on the test. So your homework is due on Mondays, Tuesdays, and Wednesdays, and then every other Thursday at 2 p.m. There is a 10% penalty for late assignments. If you have any questions, see me after class. Hello everyone, I am Professor Astrid. Welcome to the class. This is Calculus 7. Today we're going to be doing some mathematics. So we have to find the derivative of this function, but there's a square root. So what we can do then is just get rid of the square root and write it like this. And we're being really abusive here. I'm using the same function, but it doesn't really matter that I'm using the same one. We can just rename it, put a little tilde over it, and now we can take the derivative without having to worry about the square root. It's a conceptual move, not an algebraic one. So we know that the limit as x approaches a of f of x, we know that limit exists, and we want to take the absolute value of that limit. Well, I'm being abusive here, but what we can do is we can just put the absolute value inside the limit and create this inequality. So a little bit abusive here, so abusive notation. Make sure you fill in the gaps on your own time. We don't have time for it in class. If you want to succeed in this class, you should do all of your homework, go over all of your notes, and do every single problem in the book. Hello, I am Professor Hagenberger, and I like hamburgers. Hello,
Well, this might work too, though. We don't know.
It might, yeah. That's why we're here. Whoa! What that V is for, though, to try and stop those ricochets coming up, because that's exactly where that would have.
Brian, I mentioned my own love for it. I feel like I want to slash at something. This?
That is one of the sharpest swords I've ever come across. It's wicked scary.
The cuts lacerate almost in half.
Without a doubt, your weapon will kill.
Awesome.
Ben? Gentlemen, to test the strength and durability of your edges, I'm going to attack these fully armored knights. But this test is all about what the armor does to your sword, not what your sword does to the armor. Brian, you're up first. Are you ready?
Absolutely.
Well, Brian, your edge held up really well. It's a very obtuse grind that lends itself to this kind of test. The handle was comfortable. It's a nice shape. I was able to index very well. It stayed straight in the tests and didn't pick up any damage. Well done.
Thank you.
David, you're up next. Well, Dave, you have a much finer edge on this sword, and it's picked up a little bit of rolling. There's some edge deflection right here. You can hear it. But all in all, very good sword.
Thank you, sir. All right, gentlemen, next up, the swinging sandbag slice. I will cut this rope with one edge of your blade, releasing that sandbag, and then cutting that with the other edge of your blade. Let's see if they still have an edge. Brian, you're up. Are you ready? First off, there are sections of this blade that just don't have much of an edge. That first cut and just skated up the rope. Second cut, bit in, went right through. You can see how there's a lot of tearing at the edge of that bag as opposed to a clean slice through it. I would have loved to have seen a little bit more edge, especially on that front half. David, you ready?
Absolutely.
Okay.
A little bit of rolling.
Thank you.
David, you're up. Edge, very good.
Sandbag slice, and then cutting that blade. Let's see if they still have an edge. Brian, you're up. Are you ready? That edge, especially on that. Your sword's sharp, very sharp. Pass through the rope, no problem. Pass through the bag, no problem. As far as the design of your sword, would have loved to have seen a counterbalance on this. This would be nice on a dagger. It's very small for this sword. Without that counterbalance, all that weight is so far forward, but it's a cutter. It's definitely sharp. Nicely done.
Thank you.
Bladesmiths, the judges have completed their deliberation and they've made a final decision. Sword did not.
Bits at home. I still have holy water at home. Anything can happen.
Showed me that. Bike and go for a ride.
All right, everyone. Can we connect via the tutorial in our actually I've added also Fairer. Can we connect using the other one? You know, the one we call this the calendar event. So we disconnect this one and we connect via the tutorial version. Is that all right? You can see it in your calendar event.
Oh, okay.
Okay. All right. Can you guys see the shared document that I've shared with you guys?
Oh yeah.
Yeah.
Yeah. So you can see that your name is I'm putting in your name and a space for you to key in your answer. If you have already started answering, you may paste it in. Yeah, paste in your answer. All right. So type in if you haven't a chance to do yet. Okay.
tutorial like this. Tutorial like this is better.
Oh, okay. Good. All right. So from now on, we'll do like this lah.
Yeah. Okay. In the midterm, will we be in trouble if we directly copy from the lecture notes?
Yes.
It will be in trouble.
Yes. Yes. Definitely yes. Also same as the exam lah. That's considered plagiarism.
Is there plagiarism like minimum like how much and then you get punished like 10%? Under 10%.
As long as you got it's judged individual by individual question. You'll be penalized for that particular question.
Will the question be mostly open-ended or is it?
Yeah, open-ended.
Open-ended. Okay.
Yeah, and expect, because you are degree students, expect that the question will be critical thinking type open style. Okay.
1 hour. I'm afraid cannot. because when we submit, does it count? Do we also get extra time to submit? Or do we just
that 1 hour? Yes, that 1 hour is solely for doing the questions. The 15 minutes is for submission.
Okay.
Yeah. So don't worry, the questions are not that difficult, right? So basically, you will see some very similar to our what, but of course there will not be question like name and explain one reason. That is too.
That is too similar. Cannot try too hard to.
Yeah, so they will ask you in a roundabout way, so that means the question will ask your understanding. If you understand the concept, basically no matter how the question asks you, you will know what the question is asking about and you will know how to answer. Okay, but the question will not be straightforward, right?
Okay.
There will be maybe something like this question number. Let me see. Question 3B, for example, it says refer to the exhibit. The exhibit shows a small switch network. This type of question, right? Then you have to apply your knowledge on to answer the question. Yeah. So questions like, what happens if no device on the line responds to ARP requests? This kind of questions, that means it's not so straightforward asking you just, oh, what is ARP, something like that. Okay? You ask this kind of questions. Questions like part 2, discuss how a computer can use ARP to break security. This kind of question, not so straightforward, right? So even if you can find the answers in your notes, try to answer in your own words. Okay, don't just simply take and then maybe just change wording. Okay, that depends on the marker. If the marker consider that as dissimilar enough, then they will accept. Okay, but some students just change certain words and like that. But overall, the answer is still basically very similar. That one is very risky. Okay, try using your own words to answer. Of course, the terminology you still have to use the correct terminology, but the way you answer it. Okay. So Noel, on question 1A, part 1, your answer is actually pointing to the MAC layer, not the MAC layer itself. In fact, the conversion of bits into data signals, that is the physical layer. So you need to revise that, okay? That match the data encapsulation. All right, the question 1A, part I. Yeah. So for Farrer, the cut through the cut through is different from store and forward. Cut through switching, it does not, the switch does not wait until it receives the entire frame. It doesn't receive the entire frame. The moment the frame starts entering the switch straight away de-encapsulate the part where the header part, yeah, to retrieve the destination MAC address. And if the destination MAC address match in its MAC address table, it straight away start forwarding the frame. The moment it is okay, that means after it gets the header, if it's okay, it'll start. It doesn't put in the buffer. It straight away take the remaining part of the frame from the incoming port to the outgoing port. Okay, so it straight away transfer it. It doesn't even store it in the buffer for cut through. This makes the cut through very quick, right? Very quick. So you can see in the comment there, only partial means the header. The header part is received, it's straight away grab the MAC address or destination MAC address, and then it compare. If it match, straight away the remaining frame is forwarded directly, not even stored in the buffer. It's straight away take the bits as it pass through the incoming port to the outgoing port. That's cut through. Store and forward is the one that, okay, it receives the entire frame because it checks it needs to check the FCS, which is at the trailer. So it will buffer the entire frame first for store and forward, right? Whereas cut through, it doesn't check the FCS, the CRC. Straight away, if it finds the port, outgoing port, it straight away transfer it to the outgoing port. So cut through is suitable for very stable network. Okay, the switch trusts that the network is good enough that there's no corruption happening, so it doesn't even bother to check the FCS. Okay.
Okay, so cut through is faster, and because it does, because it doesn't need to check. Yeah, but it's very vulnerable to.
Yeah, that's why you will use cut through if you're confident about the stability of your network, your LAN. Because if your network is really using STP, shielded twisted pair, and it's quite stable, then you can reduce the overhead of checking the FCS. Okay, highly unlikely that there's a corrupted frame because it's like, well, the cable you use is very good STP, shielded twisted pair, and all this. So you will know because you are the network administrator. You know that your network LAN is very stable. So even if the switch doesn't check the FCS, because there's not the possibility of corruption is very low, so you will use cut through to make it fast, right? That's the reason. So don't use cut through. If you think about it, don't use cut through on a normal LAN, okay, where you're not using STP, using UTP, and you did some benchmarking and you see that percentage of corruption is not that low, so you don't really trust the LAN. Then don't use cut through. Use store and forward. So Noel, for the question where it says that in internet different MAC addresses are used for, it's good. That's what we want. You gave the example MAC addresses, but also please provide some information. What is unicast? You can say that unicast basically is a one-to-one communication, and then you give the example. Multicast is what, and multicast is what. Give some description to it.
Okay.
So, Farah, are you stuck at the question 3A1?
Yeah.
The question is, how many responses does the computer expect to receive when it broadcasts an ARP request? Now, ARP request is always broadcast. We know that. But although it means it's broadcast means every computer in the network will receive the ARP request. But not every computer will basically pick it up. Why? Because the ARP will also look at the IP address. If the IP address is not match its own IP address, then it will just drop the ARP request. So the only computer that's going to pick up the ARP request is the one that's going to match the IP address. Because remember, although we don't have the MAC address, we do still have the IP address. So when we send the ARP request, only the frame level is broadcast. The MAC address is broadcast, but the IP is still the IP that the computer you want the MAC address from. So the answer is only one. The computer that match the IP address will respond to the ARP request with the MAC with its own MAC address. Okay. So the answer is one response. Why? Because only one device on the LAN will have to match the IP address in the ARP request. All other devices will not reply because their IP address don't match. Yeah, because that device that respond, yeah, matches the IP address within the ARP request. The other computer, the IP address don't match, so they will not respond. Okay, the rest okay. Understood that part? When a computer sends out an ARP request, it knows the destination IP address, but it doesn't know the MAC address. That's why it sends out the ARP request. So the IP address is still there, the destination IP address. Okay. So even though it's broadcasted to every computer in the LAN, only the computer that matches the IP address will respond to the ARP request. Okay, so you should answer like this. Because only the one device that matches the IP address of the ARP request will respond. The other computers will not respond because their IP address does not match with the, yeah. Okay, correct already. Okay, so the last one from Noel. The duplex and bandwidth settings match between the switch port and the connected devices are critical. What can be the problem if duplex setting does not match between the switch port and the connected device? Okay, the problem to happen is that we're not able to perform auto negotiations. Right? Okay, correct. Problem to happen is okay. So it says, in what situation this problem will happen? In addition to that, in addition to that, maybe it, when I just answer when one side of the link one has been configured and the user forgot to configure the other side of the link. Okay. All right. So the way it works is that both sides of a link should have auto negotiation on, or both sides should have it off. Not like one on, one off. Okay. Yeah.
If auto negotiation also can.
Yeah. Both must be off. If you don't want to have auto negotiation, then both should be off.
So the
result, the result will not be good lah, right? Because no auto negotiate. So, but if you want to have the auto negotiation, both must be on or both must be off. If you on off, then there's a conflict happen.
So even though off, the network still can function.
Yeah, it's just that they will not be able to know whether to flip to duplex or half duplex or full duplex. They will operate. They'll try to operate. They force themselves to operate what they are having. If they're duplex, no auto negotiation, so they will just work on duplex. So duplex with half duplex, of course, the network connection will not work lah. There will be collision happening. Yeah. So, of course, the idea will be both on lah. So, auto negotiation means the switch and the device will figure out between each other. Okay, you are half duplex, I am full duplex. Since I cannot operate full duplex, I will switch to automatic switch to half duplex. So, even though slower, but still can communicate. So that's the purpose of auto negotiation. If at least one of them is not on auto negotiation, it depends lah. If that one is half duplex, yours is auto negotiation, but your so you have duplex also, so can work lah. But if suddenly your half duplex, sorry, your full duplex, you turn on auto negotiation, but the other one half duplex, the other one may be able to work on with half duplex, but since it's not set to auto negotiation, it doesn't know whether the other party is full or half. So what it is configured with, maybe half duplex, it will run with that. So there's a mismatch happen, and then you have to manually go and check lah why your network is something wrong, cannot communicate properly.
No.
Yeah, the mismatch will happen lah. Auto negotiation is to avoid mismatch happening automatically. Yeah. Okay, there's two types of duplex settings of full duplex, half duplex, correct? The half duplex can only send information one at a time, and what is right are able to send or receive simultaneously. Yeah, that's correct. Half duplex, only one type of communication at any one time, correct? Well, the full duplex is able to send things both and send receive simultaneously. Okay, yeah. Send and receive. The keyword here is both end can send and receive simultaneously. Okay. Whereas a full duplex can only send one type of information at one time. You send, then you send. If you receive, then you receive. You cannot have both at the same time. Correct. So okay. So let's go through before we end. I think we have answered all, right? I've marked all as well. Yeah. Okay. All right. Thank you very much. Well done today.
Okay.
All right. So yeah, please do revision to prepare for next week's chapter 1 to 5. Okay. If you have any question, you can message me on WhatsApp, or you can gather all your questions and you can ask me. We meet next on Friday, right?
Yeah, the practical.
Yeah. Okay. So if you have a lot of questions you want to ask on Friday, also can. If you can't wait, you want to ask, you can use the WhatsApp, the WhatsApp group we have. All right. Thank you, everyone.
Okay.
Okay, sir. Thank you.